Hi, welcome. My name's Steve. I'm a former maths teacher and still maths advocate, and I'm going to have a go at the Intermediate Maths Challenge from February 2020. It's a 60-minute paper of some interesting maths problems, and it's set for pupils in year 10 and 11 plus the odd year 9 to have a go at. So if you are in an English school having a go at this and preparing for it, I'm going to go through them. I've not seen the questions before, so I'm going to go through it and give you my insight into how I would approach the questions, and then at the very end we're going to mark it. So if you want to have a go with me, in the link to the description down below there is a link to the actual paper, so you can pause the video, have a go at the paper yourself, and then see what you got compared to me. Put your mark, you can even give yourself in the comments below, put your score. But if you have or haven't done one of these before, I'm just going to go through the general gist of how they work. If you're a student doing these for the first time, the chances that you finish the paper are pretty low. Even the best of the best, there'll be the odd question where you can't find a quick way of doing things and it will take you a long time, so don't expect to finish the whole paper. If you get stuck on a question, skip it and that sort of thing, you can come back to it. But the way that scoring works is the first 15 questions are worth 5 marks, and there's no penalty if you guess those wrong. They're all multiple choice. So for the first 15, if you're doing this for yourself next week or whenever your school's doing it, if you guess any of the first 15, you can't be penalised. The 10 questions after that are harder. They're worth more marks, but you lose marks if you get them wrong. So if you get question 16 to 20 wrong, you lose a mark, and question 21 to 25 you lose 2. But all of those questions are worth 6 marks. Now, definitely, if you're not sure about those, don't guess those. The papers are very good at giving you good wrong answers that look like they could be right. So be very careful about guessing on those. My general gist of how to do these is to work out what you think the answer is and then see if it's there. And that way you're not going to be misled by the answers they give you. And the style of these questions is different. It's different to any sort of exam you'll do. They're a lot more mathsy, abstracty. There's no real world problems necessarily, and problem solving. It's all problem solving questions. So don't be worried if you're struggling on this style of math. It's probably because you've not encountered it before. Even if you're doing this as an adult, it's just a different sort of math. So we're going to, oops, I'm going to turn my phone on mute. So we're going to give this a go. I'm going to look at the time. So it's 5 minutes, it's 2 minutes past 5. So I'm going to give myself 60 minutes from that point. And we are going to move on. So question number 1. What is the value of 2 subtract 3 subtract 4 in brackets, subtract 5 subtract 6 subtract 7 in brackets? Alright, so we're going to do 2 subtract 3 subtract 4 is negative 1. And we're going to take 5, take 6, take 7 is a negative 8. 2 subtract a negative 1 is 3, subtract negative 8 is 11. Which of these is a multiple of 24? For it to be a multiple of 24, it needs to be a multiple of both 3 and 8. So this is a multiple of 8 but not 3. This is a multiple of 3 but not 8. I imagine it's 600. Yeah, so 600 is 3 200s, and it's also 8 75s. So I think it's that. Yeah, it's 24 25s actually. It's 24 25s because 24 squared is 576. So yeah. What is the difference between 25% of 37 and 25% of 17? Can I do this without working them out? So my guess is it's going to be B. That's my guess. Let's see if I can prove it. So we're saying it's a quarter of 37 subtract a quarter of 17, and you can factorize this. This is the same as a quarter of 37 take 17. But this is 20, and a quarter of 20 is 5. You could have worked those out separately, but that's what I said at the time when you're looking at about whether you're going to run out of time in this. All of you can do 25% of 37, 25% of 17. The numbers aren't nice, but you can do it. I'm usually looking for an elegant way when I do these, just to save my time. What fraction of this diagram is shaded? Well, it's more than a half because the white sections are smaller than the shaded sections. So I'm just gonna, can I do that? I can count squares. So that's a square, that's a square, those together are a square, those together are a square, those together are a square, and those together are a square. So I think the white bit is made up of 6 squares. 2 full squares and then 4 lots of half squares effectively. So the white bit is made up of 6, which means the shaded bit out of 16 must be made up of 10. So we're looking for 10 out of 16 squares are shaded, which is 5 out of 8. Don't know why I changed colour. 4 of the following coordinate points are the corners of a square. Which is the odd one out? So we could plot this, but to get so we could plot this. It's a quicker way of doing it. Two subtract 3. Ooh. I don't like plotting this. You could work out distance between each set, and that's just going to take ages. Yeah. I'm going to give a rough sketch. This is going to be a rough sketch, and it might give me an idea of what's going on. So we'll go up to 8 there, and we'll go up to 6 there. So 4, 1. So 4, 1 is there. 2, 4. 2, 4 is about there. 5, 6. 5, 6. 3, 5. 3, 5. And 7, 3, 7, 3. So my guess is it's going to be that one, but it's going to check these two. So what we're looking for, the distance between this point and this point should be the same as the distance between this point and this point. So this is 1, 4. So this, apologies, this is 4, 1 and this is 7, 3. So you go across 3 and up 2 to get from there to there. To get from here to here, if we start at 5, 6 and subtract 2 and subtract 3 from the y and the x, so it should be 4, 2. It's going to be that one. So I think it is D. There might be a more elegant way of doing that one. But yeah, basically I've gone down 2 and across 3 to get from that to that. So I start at this point, I go down 2 across 3, I get to that one. And so this is the odd one out. But a little sketch gives us the one that doesn't look right. AJ, I plotted it to find which two are closest and worked out from there. So same method, I think. Which of the following has the largest value? Okay, well, it's not that one. That's 36. That's 125. That's big. 2 to the power 6 is 64. 3 to the power 5, 243, I believe. And 4 to the power 4, so that's going to be 64 times 4 is 256, I think. So I think it's that one. Kartik wants to shade 3 of the squares in this grid blue, and Lucy wants to shade the remaining 2 squares red. There are 10 possible finished grids. How many finished grids are Lucy's red squares next to each other? Well, we don't really need to, if all of them are going to get coloured in, we don't need to worry about the blue ones. We just need to think about all the combinations that Lucy can have 2 red squares. So she can have that, 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 that. And how many of those are next to each other? We've got 1, 2, it's probably going to be 4. Yeah, so in each case, if Lucy picks this one, once it will be, this one will be the same. And then when Lucy picks this one as her first one, once they will be there. So it'll be 4 different ways of doing it. Out of the 10, you can see there's 10 combinations here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there's 4 pairs. One of these options gives the value of 17 squared plus 19 squared plus 23 squared plus 29 squared. Which is it? Well, they all end in a different digit. So I'm just going to say 17 squared must end in a 9. 19 squared must end in a 1, because 9 times 9 is 81. To get the unit, you're just looking at what happens when you square the unit. So 7 squared is 49. So whatever number ending in 7 squared must end in a 9. 3 squared is 9. 9 squared is 81. So 9 plus 1 plus 9 plus 1 will give you a remainder of, a unit of 0. So I believe it's that one. Adam's house number is in exactly one of the following ranges. Which one? Okay, so we could start. I already know it's not this one, because I'm going to see if I can do it a slightly more logical way. This one starts at 123, as does this one, and this one's a wider range. So if Adam's house is in this range, it's also in this range, so it can't be that. In fact, this range also includes all of these. So this range is larger than both of these put together and includes all of them. But it has a bit of an extension. 231 to 312. Oh, it's just this one, isn't it? Because this one and this one together make this one. So there's no number that's in one of these that isn't in that, and there's no number that's in that isn't in one of these. And that's just smaller than that. So it must be this one. His house number must be 313 to 321. It's a weird question. What was the value? 2,468 multiplied by 2,468 divided by 2,468 plus 2,468. So if we write it as 2468 times 2468 divided by 2468 times 2, so we just said that we've rewritten that, you can cancel out that and you're left with 2,468 divided by 2, which is 1,234. I start at square 1 and have to finish at square 7, moving at each step to a higher numbered adjacent square. How many possible routes are there? So we've got that route, and then so that's one. I'm going to see if I've got to do this in a logical way, because you can also kind of zigzag. Yeah, so I think I know what I'm going to do. Oops, no, I don't want to do that. So we've got to finish at 7, got to start at 1. So there is one way to do it with no peaks. There is 3 ways to have 1 peak. You can have these 2, you can have these 2, and you can have these 2. So there are 3 ways to have 2 peaks. And there's 1 way to have 3 peaks. So I get 8, so I'm missing something out. What am I missing? Let's see if I can work out what I'm missing before AJ jumps in. So my guess in this case is it's 9. Am I missing one? So, moving each step to a higher numbered adjacent square. How many possible routes are there? You have to start at 1, have to finish at 7. So effectively you've got 1, 3, 5, 7, 1, 2, 3, 5, 7, 1, 3, 4, 5, 7, 1, 3, 4, 1, 3, 5, 6, 7. That's for those. And then to have two peaks, you're just missing out each of the even numbers, aren't you? So you've got 1, 3, 4, 5, 6, 7, 1, 2, 3, 5, 6, 7, and then 1, 2, 3, 4, 5, 7. That's those. And then there's one way to do it using all of them. 1, 2, 3, 4, 5, 6, 7. What am I missing? I start at square 1 and have to finish at square 7, moving at each step to a higher number adjacent square. How many possible routes are there? What am I missing? Oh, I'm missing that one. Oh no, I'm missing a lot more. I'm missing a lot more. Because I can go and miss out, I can miss out 3 and 5, or I can miss out 3 or 5, so I can do that. Yeah, so I can miss out 3 and 5, and 3 and 5. That's another 3 on top of my 8, so I think it's 11. Yeah. But it's a good thing 8 wasn't our answer. I would have got that wrong. Farmer Fatima rears chickens and goats. Today she returned from the market and said, I sold 80 animals, and now there are 200 fewer legs on my farm than before. How many goats did she sell? So we want the total number of animals to equal 80, and we're going to call chickens X and goats Y, and the number of legs to equal 200. Well, the number of legs will be 2 times the number of chickens, because chickens have 2 legs, and 4 times the number of goats. So we're just going to solve a simultaneous equation. We're going to double the top one. And subtract this one from this one. So we're going to subtract 2y is 40, y is 20. So I want the number of goats, y's number of goats is 20. What is half of 1.6 times 10 to the 6? That is just going to be 0.8 times 10 to the 6, which is 8 times 10 to the 5. Here. The result of the calculation, 9 times 11 times 13 times 15 times 17, is the 6-digit number 3n8185. What is the value of n? So there is a trick. Anything in the 9 times table, which this number will be because it's multiplied by 9, has a trick that the sum of the digits will be a multiple of 9. So we know that 3 plus n plus 8 plus 1 plus 8 plus 5 is some multiple of 9. So 3 plus 8 plus 1 plus 8 plus 8 plus 8, 16, 17, 22, 25. So n plus 25 is a multiple of 9. And the closest multiple of 9 to 25 is 27. So it needs to be 2. AJ said this one for me. He missed it first time he looked at it, but you did get them all right, I believe, AJ. So well done for working it out. This is my favourite area of maths. It's called number theory. Multiplication tricks, division tricks, divisibility tests, all that sort of stuff. Factors, primes. It was my strongest area at university maths. It's because I enjoyed it. That's why. I mean, I'm good at things I enjoy. That's the long and short of it. So you've got to make sure you enjoy what you do, I guess. Triangle PQR has been divided into 25 congruent right-angled triangles. So congruent means for those of you not sure. Congruent just means everything's the same, all the sides and angles are the same. The length of RP is 2.4 centimeters. I'm going to do it on the big diagram. 2.4. What is the length of PQ? So we know that this length, the length of one of them is 0.6. So that's one hypotenuse. So of our triangle, the hypotenuse is 0.6. Yeah. So RQ, oh yeah, so RQ would be 1.8, and because these are congruent, that's a right angle, which means these two angles must add up to 90, which means these two angles must add up to 90, so that's also right angle. So the whole triangle is a right angle triangle, which means we can use Pythagoras. So 1.8 squared times 2 plus 2.4 squared is this squared. But this is just a 3, 4, 5 triangle. So if you divide by 6, multiply by 10, so it's going to be 3.0 or 3, I believe. I've done that in my head. All I've done is scale it up to 5 and then I scale it back down again. So if you divide by 6 you get 0.3 and then times by 10 you get 3. So divide by 10 you get 0.5, times by 6 you get 3.0 or 3. Oh, thanks so much, you make no sense. 4-month subscriber, what a star you are, thank you very much. Is it exactly 5, is it? Yeah, there's probably another way of doing it. I reckon what you can do is find things lined up with other things and make them equal. You know that 4 of these equals 3 of these, and so on like that. I'm not sure you could do it that way, but that's the way I spotted. I think we had, well, as a decimal, what is the value of 1/9 plus 1/11? I think we had one like this before, and I'm going to do it the way I did it last time. I'm just going to add them together. 1/9 plus 1/11 is the same as saying 11 over 99 plus 9 over 99. It's going to be 20 over 99. And I actually know that one off the top of my head. That is that one. But you could just divide. You could see how many 99s go into 20. You'd keep going forever and ever and ever. But that's how you check you were right. I actually just know that fact, that things over 90 and 99 have come up so often that I just know them. But the point is that this goes on forever and ever and ever, and this goes on forever and ever and ever and ever. That it's unlikely to be a finite amount. To get a finite amount, you need, I've forgotten what the word is, but basically you need the denominator of the fraction to be a multiple of 2 or 5 only. So if your denominator does not have a factor of 2s and 5s only, it will not terminate. There we go, that's the word. So weirdly, I actually know, because all of these other options terminate, and this won't, because the denominator will never be a multiple of 2s and 5s only. So you know, just if you're looking for fractions that terminate. I used to be a maths teacher, you make no sense. I'm sure you knew that. If you have a half or a quarter or an eighth or a 40th or an 80th, all of these will terminate because the denominator is made up of 2s and 5s only. The Knave of Hearts stole some tarts. He ate half of them and half a tart more. The Knave of Diamonds ate half of what was left and half a tart more. Then the Knave of Clubs ate half of what was remained and half a tart more. This left 1 tart for the Knave of Spades. How many tarts did the Knave of Hearts? So how many tarts are stolen in first? So we've got spades, clubs, diamonds, and hearts. So spades were left with 1. That means the clubs ate. There were 1 1/2 before they ate the half, and then they ate half of them, so that's 3. So all I'm doing is adding a half and doubling it. So adding a half, 3 1/2, doubling it. Adding a half, 7 1/2, doubling it. I think there were 15. So basically, if they eat half and take a half off, to reverse it, you add a half and double it. So I believe that gets you 15. Let's just double check that. 1, 1 1/2, 3, 3, 3 1/2, 7, 7, 7 1/2, 15. At least 15 is one of the answers, so I think it's 15. But what you could do if you had time at the end is you just start with 15 and you do the maths. Diagram shows an isosceles right angle triangle which has a hypotenuse of length y. The interior of the triangle split into identical squares and congruent isosceles right angle triangles. So because these are isosceles, you know that this length is the same as this length, which means this is going to be half a square. So that's more important. We need to know that this is effectively half a square. Work out the total shaded area inside the triangle. Which one's y? The hypotenuse. So we know that this is y. So we need to work out the area of these four added together in terms of y. So to do that, I'm going to work out this length, because if I know this length, I can divide it by 4 to get one edge of the square, and then I can work it out. So this length is going to be, we know that 2x squared is y squared. Root 2x is y, so x is y over root 2, or root 2 y over 2. I've just rationalised it, that's all. So we know that x, or this length here, is going to be root 2 lots of y over 2. And so to work out this length, we're dividing this by 4, or working out a quarter of this. So this length here is going to be root 2 y over 8. So to work out the area of 4 lots of these, we're going to square this and times it by 4. So to work out the area of one rectangle, we're going to square it. So we're going to do root 2y over 8 times root 2y over 8. But the good news is this is what gets us our y squared. We're going to get 2y squared over 64, which is y squared over 32. And then we want 4 of those, so we want 4 lots of y squared over 32. It's going to be y squared over 8, which is the middle option. You make no sense, is that Ella? Or is that someone else? I can't remember who's who. MC squared's AJ. The diagram shows 2 squares and 4 equal semicircles. The edges of the outer square have a length 48, which is already written on, and the inner square joins the midpoints of the edges of the outer square. Oh, yes, apologies, Andy. Yeah. How are you doing? Each semicircle touches 2 edges of the outer square, and the diameter of each semicircle lies along the edge of the inner square. What's the radius of each semicircle? Okay. So we're trying to find this length. Which means, is there a way for me to work out that length? I'm not sure there is. So we do know that is a right angle. And if we can work out that length, we can work out this length, because it's going to be the same as that. So to work out this length, if we knew the length of the sides of the square, which we can do actually, can't we? So I'm going to just do a bit of a blue pen. This might take a long time. So this length here is 24. as the same as this length, because this is an outer square. So we can work out the length of this, because it's going to be 24 squared plus 24 squared equals, we'll call it x. So 576 doubled is 1100, and I'm just going to write it down, 576. 576 is x squared. Because the thing is, if I can work out half of x, I can work out this length here, and if I work out this length here, I can work out this length, and then take it off 48 to get you 2 of the radiuses. Yeah, thanks AJ. I can say, instead of that, I can say it's 2 times 24 squared, or root 2, 24 root 2. Which means one length of this is going to be 12 root 2. So this length here is 12 root 2. Yeah. So to work out this, we're going to call it y. We've got 12 root 2 squared plus 12 root 2 squared is y squared. 12 root 2 squared is going to be 2 lots of 144. And so in total, this is going to be 4 lots of 144 is y squared. So y is going to be the square root of this, which is just going to be 2 times 12. And 2 times 12 is 24. So y is 24. This length here, this red length here between the 2 dots is 24. If we take that 48, we're left with another 24, which means each of these red lengths must be 12. And we're looking for the radius of the semicircle, so it's just going to be 12. Right, they start to get hard now, so remember, if you're doing this yourself, don't guess if you don't know. If you get an answer that's not there, don't guess. You need to be making sure you know what the right answer is. For any fixed value of x, which of the following 4 expressions has the largest value? I think it's just going to be the last one. Because if you expand this out, you get x squared minus 1, you get x squared minus a quarter, you get x squared minus a ninth, and you get x squared minus a 16th. Now, for any value of x, this is going to be at least 0 or positive. And so whatever the value of x is, it's going to be the same, and you're taking off the least in this last option, which means it's going to be the largest value. So whatever x is, any fixed value of x, you take off 16. In fact, any value of x, because x is always going to be at least 0, this is going to be the largest value. So it's going to be that. Just a general hint as well, it's almost never that option. I don't think maybe I've seen it once where they sometimes give you an option where I need more information, or it depends, that sort of thing. Usually that's not the case. So if you're ever going to guess, if you're going to get to the point where you guess, never guess that option. And if it's that option, then post this video and I will apologise to you directly, but it just isn't. It just isn't. It's just a get-out clause. You think, oh, I haven't got enough information here, or x could be anything. It could be, and it's just, it's not. It's basically giving you a false wrong answer. So don't go with that one. The diagram shows 4 semicircles, 1 with a radius 2, touching the other 3 which have a radius of 1. What is the total area in centimetres squared of the shaded regions? Okay, so we know that the radius of this one is 1. These are 1s, and these are 1s. And the radius of the whole semicircle is 2. Now, my first reaction is that this is an awkward shape to work out. So I'm probably going to deal with the white shape. I'm probably going to work out the area of half the circle, or the semicircle, and take off the white bits. But my other thought is that this shape here is also difficult. So I need to find a way of getting rid of that shape. And I think if we draw two squares, because I think that's a square, isn't it? In fact, we just draw one rectangle. There we go, that's a rectangle of height 1 and width 2. And then you're left with a quarter plus a half plus a quarter. So you're left with a full circle. So basically, we've got this rectangle, which has an area of 1 times 2, or 2. And then you're left with a full circle. This is a quarter circle, this is a quarter circle, this is half a circle. And that full circle will just be pi r squared, or just pi, because r is 1. So the total of the white areas is just going to be pi plus 2. And the total of the semicircle, which we're going to work out, will be pi times 2 squared over 2, because it's a semicircle. And then we're going to subtract the white bits. So pi times 2 squared is 4, divided by 2 is 2 pi, subtract 2. So we think it's just going to be pi subtract 2, which is that option there. Right, in terms of time, we are just over half our allotted time. We've got 4 questions left. This feels like one of the easier intermediate ones that I've done, assuming I haven't gone wrong. The diagram shows a regular pentagon and irregular quadrilateral. What is the sum of the 3 marked angles? Well, if the pentagon's regular, I know from memory that that's 108. So that's 108. Which means this angle here is going to be 360 subtract 108, it's going to be 252. And weirdly, these 3 angles will just be 360 take 252. Gets you back to 108, I believe. And for those people who aren't sure, to work out an interior angle of any shape or regular shape, if you work out the exterior angle first, because all the exterior angles will be the same, to work this one out, you just do 360 divided by the number of sides, so it would be 72 in this case. So 360 divided by 5 is 72. That's how you get 108, but it's just one I know. Five congruent triangles, each of which is half a square, are placed together to edge to edge in 3 different ways, as shown to form shapes P, Q, and R. Which of the following lists gives you the shapes in ascending order of the length of their perimeters? Okay, so we're looking at shapes made up of this shape. Now, this is a half a square, which means the length, let's say it's 1, 1 and root 2. So we can work out the perimeter of this is going to be root 2 is about 1.4, 1.41 or something like that. So to work out, the Discord is going off on one. I need to mute it somehow. Can I mute Discord? Alright. Okay. I'm just going to turn my speakers off. That might be the easiest way of doing it. Right, so let's get back to this. We have, this one is going to be 2 plus 3 root 2. So basically it's 1, 1 and then 3 root 2's. This one's going to be 1, 1, 1, 1. That's going to be 1, 1. That's going to be 6 plus root 2. And this is going to be 1, 2, 3 plus 3 root 3. So it's 3 plus 3 root 3. 2. So the value, and this might be not a nice way of doing it, but the value of this is going to be 3 lots of 1.4 is 4.2, so that's going to be 6.2. This is going to be 7.4. This is going to be 3 lots of root 2 we've just done is 4.2. So that's going to be 7.2. So using a rough estimation, there might be a more elegant way of doing that. I think that the ascending order of the lengths of the perimeters is P, R, Q. P, R, Q is the last one. Positive integers m and n are such that 10 times 2 to the power m is 2 to the power n plus 2 to the power n plus 2. What's the difference between m and n? Oh dear. Positive integers m and n are such that 10 times 2 to the m so we could say 10 times 2 to the m is the same as 2 to the n, lots of 1 plus 4. Well, basically 2 squared is 4. So I think that's 10 times 2 to the m equals 5 times 2 to the n. And for these to be equal, n needs to have one more 2 than this, because this is the same as 5 times 2 times 2 to the m is 5 times 2 to the n. And so you can see that 2 to the n must have one more 2 than 2 to the m. So whatever m and n are, the difference between them is 1. That looked much more difficult than it ended up being. Oh dear. The diagram shows 6 points P, Q, R, S, T and U equally spaced around a circle of radius 2. The inner circle has radius 1. The shaded region has 3 lines of symmetry. Which of the following gives the area in centimetres squared of the shaded region? Alright, so for it to have 3 lines of symmetry, it's basically saying that that's a line of symmetry, that's a line of symmetry, that's a line of symmetry. Does that mean we know, do we know for sure if P's in the centre of this arc? So did it say they were equally spaced? Yeah, so they're equally spaced, which means weirdly you actually know that your circle is split into sixths. So a big circle split into 6 pieces, which means that that is a sixth of the circle, but you've got 3 of them. Q and T must be opposite each other and so on. So weirdly, if I'm looking to split this shaded area up, whenever I get one like this, I'm either looking to work out the whole circle and take off the white bits, or to split the bit I know, the bit I'm trying to find out, into bits I can do. And because we know that this point here lies on this centre circle, I think we can work out the area of this shape here. So we can definitely work out the area of this shape and this one and this one. So these shapes will be just a sixth of pi r squared. So if we work out one of these, it's going to be a sixth of pi times 2 squared. And that will be 3 of those will give you a third of pi times 2 squared, so 4/3 pi r squared. Yeah, so we can definitely work that out. So can we work out the area of this quadrilateral here? Yeah, I think if we split it like that, this might not be the nicest way of doing it. If we split it like that, because we know they've got lines of symmetry, and because we know these are equally spaced, we know this whole angle is 60, which means that angle there is 30. And we know that's 1 and that's 2. So the area of this shape here, this one here, we can use half AB sine C, which is going to be, because we have an angle on the 2 sides either side of them. So this shape here, just this triangle, and we will have 1, 2, 3, 4, 5, 6 of these. It's going to be half times A times B times sine of 30. Now sine 30 is a half. Half of 2 times a half is just going to be a half. And we have 6 of those. So the triangles will be 6 lots of a half, will be 3, and the wedges, if you think of Trivial Pursuit wedges, is going to be a sixth times pi times r squared, and you've got 3 of those. So you're going to have 12 divided by 6 pi, which is going to be 2 pi. So in overall it's 2 pi plus 3, 2 pi plus 3. Thankfully that's there. I think that's probably right. Did we miss any out? I don't think we did. So we're going to go back to the start and mark it. So if you haven't finished doing anything yet, you pause the video. We're going to get to the marking point. No, not that. Okay, so alright, and we're just going to go to the front. We're going to get our green pen out, although I have written in green at some point, and we're going to mark what we've done. Okay, so question 1 is A. Question number 2 is E. Question number 3 is B. Question number 4 is D. Question number 5 is also D. Question number 6 is C. Question number 7 is B. Question number 8, I need to scroll down, is E. Question number 9 is E. That's a weird question to have in here, that one. Question number 10 is B. Question number 11 is, I've got this one wrong. Oh, this is fine. I mean, it's actually 13. So I got this one wrong. What did I miss out? Oh, it's a Fibonacci sequence. There's one way to do that. There's one way to do that. But to get to, there's one way to get to 1 to 2, one way to get to 1 to 3. But to get to 3, there are 2 ways. To get to 4, there are 2 ways from 3 and 1 way from 2. So basically, 1, 1, 2. There are 2 ways to get to 3. 4, you can either get it from 2 or from here. So there's 3 ways to do that. 5, if there are 5 ways to get from 2 and 4 separately, you can get 5 and then 8 and then 13. Yeah, that's quite nice actually. I missed that. So the answer's 13. I said 11. I got one wrong. 12 was B. 13 was C. 14 was A. 15 was A. And now we get onto the ones where we get wrong. So if you get any of these wrong, the next 5 you're going to lose a mark, but you gain 6 if they're right. So 16 is E. 17 is also E. 18 is C. 19 is B. 20 is, I assume it's D, but I haven't got there yet. Yeah, 20 is D. Now if you get any of the next 5 wrong, you lose 2 marks. So 21 is B. 22 is C. That feels quite easy actually for a hard question. 23 is alright. What have I done wrong? Oh, that's 4. That's 4. My method was right. I just missed that out. It's 1, 2, 3, 4. So it's actually A. So I got this one wrong. So 23 was A. 24 was A. 25 was also A. So we're going to go back to the front. We're going to mark and we're going to give ourselves a score. So we got, I got 14 5-point questions right, 70. I got 9 6-point questions right, is 54. And I lost 2 points because I got question 23 wrong. So 124, 122 out of 135, and that is all we have today. So that is so one I got wrong, and then one my method was right and my numeracy was wrong. So I'm not as disappointed in that one. So I just made a numerical mistake. Yeah. Yeah. Just needed a more ordered way of listing all the ones I had in that question. I think maybe I should have gone back and checked it because it was the one I was least sure of. So that was question 32. Anyway, if you've had fun, I'm going to keep doing these. I'm going to keep posting them on my YouTube channel, and you're welcome to have a go at them first. All the question papers will be in the descriptions, and hopefully my worked solutions will help you. You know, the logic and how I approach the questions and the little tricks I kind of throw in there will kind of benefit you. That took us 50, well, just under 50 minutes to mark it as well. So you get 60 minutes in the real thing. So maybe don't go as fast as I have, and definitely use some time if you do finish early to go back and check what you've done. But if you are doing these, keep having fun. We'll be back on Sunday, where I'm going to do the senior one. Now, I don't think I've ever full marked a senior one. I've full marked intermediate ones before, but I don't think I've ever full marked a senior one. So wish me luck on that. I'm going to do a senior one on Sunday at 5 PM, and that'll be up on YouTube after I've done it. But anyway, thanks for watching. Please like, share, subscribe, and follow me on Twitch when you can see me do them live.